is Math 63, Chapter 1, Section 1.2, and we're working the problems. We're on number 11. If the first aid sign below, this guy, is scaled down by a factor of 9, find the new dimensions for the overall width and height rounded to the nearest 16th of an inch. Assume the shape to be symmetrical and all dimensions to be in inches. This is the part that I want to concentrate on first, that the shape is symmetrical. When I look at this shape, when it says it's symmetrical, that means that it's 4.5 here, and 4.5 here, 4.5 here, 4.5 here. And that 5.25 is for this guy, this one, this one, this one, and so on. And that's a really important thing to consider. So I'm going to have to scale this down by a factor of 9, which means that I'm going to be dividing by 9. Now, when I look at this, and I'm looking for the overall width and the overall height. When I look at this, I'm thinking two different ways to do this. I could first scale the numbers 4.5, 5.5 by dividing by each of them by 9, and then find the overall width. Or I could get the overall width and the overall height first. Let me overall width and overall height. I can get the overall width and the overall height first, and then I can do some scaling. And I don't know why. I think I'm going to go with number 2. So the overall width before scaling, I'll put a BF before scaling. Actually, you know what I'm going to do? I'm going to go ahead and do it all in one fell swoop. So overall width. When I start, I'm going to go from here to here. So I'm coming across here, and that distance is 5.25, 5.25. And over here is 4.5 plus 4.5 plus 5.25 again. I guess I could have just taken that guy and multiplied him by 2. All right, when I add all of this up, this is going to give me the overall width of this part. But remember, I've got to scale down. So after I do that, then I'm going to go ahead and divide by 9. So let me put this in the calculator to see what we come up with. Clear this out. 5, I'm going to use decimals, 0.25. And I'm going to say times 2, 5.25 times 2, because I'm going to pick up that guy on the other side, times 2. And I'm going to add to that 4.5, 4.5. And so I got 15, and now I'm going to divide by 9. Divide by 9. And I get that guy. Okay. So what I'm going to do is I don't like that decimal. I want a fraction for an answer. And oh, but wait, by the way, I'm rounding to the nearest 16th. Let me make a note here. Nearest 16th. So my overall width is 1, and I'm going to take off that 1, and then I'm going to multiply the decimal part by 16. And I end up with 10.6. Round that to the nearest whole number, and that's 11/16. And these are all in inches. And then I'm going to do exactly the same kind of process to find the overall height. Overall height. It's going to be from the very top to the very bottom. Okay, so that means this guy here is 5.25, 5.25, and this guy in here is 4.5 and 5.25, and so it's just like the other one. And you know, because everything is symmetrical, that would make sense that the top part, the height, no matter how I turn this cross, it's going to be exactly the same. So it only makes sense that the overall height is going to be identical to the overall width. Yeah, I like that. This is problem number 12. A stair stringer, this guy here, is going to be cut with 9 rises to reach a deck that is 68 inches above the ground. Construction code stipulates that each rise must be equal so that the staircase will not be a trip hazard. Calculate the height of each rise rounded to the nearest 16th of an inch. So here's my diagram. It's 68 inches high, and I wrote that over here, and there's 9 rises. So really all I'm doing is taking that 68 and dividing it by 9. So 68 divided by 9, let me put this in my calculator, divided by 9, and I have that decimal, 7.5 and change, 7.5 0.5555. I want you to notice something on here. Notice that the last digit on here is a 6. And the reason it's a 6 is your calculator rounded. It rounded to the nearest, I don't want to say whole number, but it rounded to the nearest number, because otherwise this would have been 5555 and so on. So I just wanted you to be aware that your calculator is rounding. Okay, now I'm supposed to do this to the nearest 16th, so the process that I've been using is going to be the same. Let me scoot this up a little bit. So I'm going to bring down the 7, and I'm going to take off the 7 on my calculator, and then I'm going to multiply it by 16. And when I do that, I end up with 8.8 and change. Rounded to the nearest whole number is 9. So I get 7 and 9/16 inches for the amount that each rise should be. Problem number 13. It says that a stringer is to be cut to reach a second-story floor that is 106 inches above the ground. And it's shown here in the picture. So here's the stringer, that the staircase that they're going to construct. Construction code stipulates that each rise must be equal, so the staircase will not be a trip hazard. We know that. We've seen that many times. Calculate the whole number of rises, so that the height of each rise is as near the ideal of 7 inches as possible. And after you do that, use the whole number to calculate the rises. Next, use the whole number of rises to calculate the height of each rise, rounded to the nearest 16th of an inch. This is kind of confusing, a little bit confusing. So one of the things that I could do is I could guess how many, let me move this up, how many rises it's going to take to get to 106 inches. So I could say, I'm going to just kind of mess around. I'm going to say 106. If I had 10 rises, then that means, I'll put it on my calculator just to show you, divided by 10, I would have each rise is 10.6. Well, that's not going to work. Okay, so I need more rises in order to bring that down. So I'm going to just try, let's try 12, see what happens. 106 divided by 12. Okay, so I'm getting 8.8, still not close enough to the 7 that I want. I'm going to pop that up to 14, see if how that works. 14. 106 divided by 14. 7.57. I'm getting closer. Let's try 15. 106 divided by 15. 106 divided by 15. So, I like that. 7.06 and so on. And I don't think I could do any better than that, to tell you the truth. But that looks pretty good. So if I get, and you can't have part of a rise. You either have a rise or you don't. So I'm going to guess that this is the next one. But just to be on the safe side, I'm going to take 106 and I'm going to divide it by 16. And I end up with, okay, let me write that down. 106 divided by 16 is equal to 6.625. So I'm really looking at these two guys here. Okay, one is below 7 inches and one is above 7 inches. This is my ideal, 7 inches. Well, which one is closer? Clearly this one is. So I'm going to say I need 15 rises, and that each one of them, so I've got this guy right here. I'm going to go back and put that in my calculator. 106 divided by 15. So I get this number, and he keeps going out. So each rise should be 7. And now I'm going to take this guy and I'm going to change it to the nearest 16. So I'm going to take off that 7 and then multiply by 16. So I get 1.06 and change, and I round that to the nearest whole number, and so that's 1/16. So for a height of 106, I want 15 rises, and each rise would be 7 1/16 inches. Now the other way that I could have done this problem is just taken the 106 and divided it by 7 just to start with. So 106 divided by 7, and I end up with 15.142 8. So that means it tells me right here that I'm really, really close to 15. Now, if I divided it by 8, 106 divided by 8, I'm going to get 13 and a quarter. But this is the guy I want. This is the ideal part right here. That's the ideal. So I know I want 15 rises, just the same as I did above. And so then once I get that, I'm just going to end up taking the 15 and dividing it in there, just like I did here. I'm still going to get the same number over here, which I'm going to have to change to the nearest 16th. So you could start with this approach, or you could go this. I kind of thought this was a little bit of fun, to tell you the truth.